Okay, guys, so this is a nice question about you differentiating between what these different molecules are and how they bond. And the question, therefore, says the following. You've got a picture of methane or a structure of methane and a structure of part of polyethene. It says methane is a gas at room temperature, but polyethene is a solid. Okay, so here's the first clue in the question. Methane is a gas and polyethene is a solid at room temperature, which is around 25 degrees. Explain why methane and polyethene exist in different states at room temperature. Great question. So, first of all, methane is a gas at room temperature. When you hear that statement, you should instantly be thinking this is a simple covalent structure. So, methane is a simple covalent structure. Now, there are lots of associations when a molecule is a simple covalent structure. One of them being is that these are molecules that have very little atoms or few atoms, and they are not joined by many other atoms to it. So simply CH4 here, or methane, is that, and that is it. That's how it's found in its simplest form. That's how you find it in your natural atmosphere. So what happens is that you have these CH4 molecules, and what they do then is they simply have very weak intermolecular forces with other CH4 molecules, and this keeps going on. Because these are gases, all right, it means that there are very few intermolecular forces between them because these particles are far apart anyway. So when they do interact, they will interact very weakly through these very weak, we call them intermolecular forces. All right, I'll spell that for you. Intermolecular. Let's just sort that out. It's a bit messy there. Try that again. Forces. And so these intermolecular forces, the word inter, you should know, or if you don't know, it means between. So what do you think intermolecular means? Well, it should mean between molecules, right? So there are weak intermolecular forces between molecules of methane. And simply because they are weak, we can say over here, we need very little energy I'm just going to write E for short, to overcome the forces. Now, it's really important that you understand three important things about simple covalent structures. They have weak intermolecular forces, which are represented by these dashed lines. And that means that they can be pulled apart very easily. They need very little energy to overcome the forces. So that's why they are a gas at room temperature. Yeah? What about polyethene, however? So polyethene is a different structure. So I'm just going to scroll down a little bit. And now looking at polyethene, we can say the following. Well, it's got a structure here which shows you part of the structure. So C with the H's. And it's n number of molecules. Now, what that n tells us is that this could be 100, it could be 1,000, it could be thousands of molecules long, okay, or thousands of these constituent units, or what we call monomers long, right? The reason it's poly and that should give you the clue. Poly means many, right? So when you hear the word poly, you should think straight away this is many molecules. So there's many molecules of ethene joined together or bonded together, right? That's what a polymer is. Lots of monomers joined together to form a smaller, to form a larger polymer or larger molecule. Okay, so it's really important then that if you understand that, then that you can then answer the question if it was regarding polyethene. So what you would say therefore in this situation is that there are lots of intermolecular forces, because this is not just one molecule like this is basically chains and chains and chains, etc. I'm just going to draw not an exhaustive amount, but just to show you what I mean. You'd have lots and lots of these polymer molecules, and then what you'd have is and if I just quickly just copy and paste this, and let's just do that. Let's put this down over here as well. Okay, and we might have another one. So these are polymer chains, and of course the polymer chains, you can see now, have lots more interactions between each other. Right, so what I'm showing over here is just a quick analogy of what I mean by lots of intermolecular forces. So you can see that not just one, you've got loads of these intermolecular forces that hold these chains together, and that's why we say that polymers like these have lots of intermolecular forces. So therefore we can say that they have stronger intermolecular forces, okay, between the molecules. And similar reason to the one previously, we can say therefore we need more energy. Important thing here is to emphasize the more, because this is a comparison between polyethene and the simple methane. We need more energy to overcome the forces of attraction between, or overcome the intermolecular forces. Yeah, and that's it. So really important here to understand that polymers can be hundreds or thousands of chains long, and the single monomer unit is here, and this continues in a long carbon chain over here, and you can see quite clearly that we've got lots more intermolecular forces, so therefore we have stronger intermolecular forces between these molecules, and that is why they are a solid at room temperature as opposed to being liquid. So if you had to then answer this question in words, and you would say something along the lines of, let's just take methane for example, and let's just say that over here that methane is a small simple covalent structure, and oops, I can't write clearly, you can see that. Let's change that away, and we can say that it has weaker intermolecular forces between the molecules, which require less energy or a little energy to overcome, and this is why it has a low boiling point. That's important to understand, that because it has a low boiling point, those molecules can be split apart very easily. And then the opposite would be true for polyethene. So I don't need to write that down. Just make sure you can spell correctly. And just make sure that you've written down those key elements here. So the key elements are that this is a much more smaller structure. Okay, if you were to write for polyethene, you would say it's a large molecule comparatively. Yeah. And the second mark is to say that you'd have, instead of having weaker intermolecular forces between the molecules in methane, you'd have stronger intermolecular forces between the molecules. And instead of writing which require less energy, you would say you need more energy to overcome the forces. And instead of writing a low boiling point, well, in polyethene, you would say that there is a much more higher boiling point. Okay, BPT for short. All right, thank you for listening.